All right, let's take an example. Let's look at another example of a real life example where a parabola would be used to model the situation. So here we have a construction worker who drops their wrench from the top of a building. And the wrench falls from the top of the building. So just imagine this wrench falls from the top of the building and it eventually hits the ground. Okay. And they give us both the equation and a graph that models the path of the wrench as it drops from the top of the building to the ground. And now they have a series of questions they want us to answer. So determine the coordinates of the vertex H and K of this problem. So for the vertex is the highest point here. In this case here, the vertex would be right there. That's the vertex. So the point there is 0, 90. Remember, x, y. Okay, so 0, 90. The x-axis is time in seconds, and the y-axis is height in meters. Okay, so the next question, from what height is the wrench initially dropped? Okay, so that occurs at time 0, right? So the wrench is dropped, and then this models the fall of the wrench. So at time 0, that's when the wrench is dropped, and they want to know the height. Well, if you look at the graph, the height there would be 90 seconds. Or sorry, not 90 seconds, 90 meters. So therefore, the wrench, remember, because it is a word, they ask you the questions in words, you must answer in words. So therefore, the wrench is dropped from 90 meters above the ground. Okay. What is the wrench's height above the ground after 3 seconds? Okay, so there's that path. That red line is the path of the wrench over time of when it initially drops off the building and then until it hits the ground. So they want to know here, after 3 seconds, how high is the wrench? So 3 seconds, that's time. So 3 seconds. We're going to take our pencil. We're just going to move up, and we're going to hit that parabola there. Okay, and then we're going to do the best we can just to do another straight line over to the y value so we can estimate the height. Okay, so 3 seconds. Find your 3 seconds on the x-axis. Move your pencil up until you hit the parabola, and then move your pencil over to estimate the y value. So you'll see here, it's between 40 and 50. Again, our tick marks or scale is going up by 10. So we're going to do the best we can to estimate that. So that would be like 44, 45. And it's approximately. So we're going to use that little squiggly. So I'm going to just say 44 meters. So therefore, the wrench is 44 meters above the ground after 3 seconds. Okay, that's the 44. If you said 45, that would work as well. It's between 40 and 50 there. All right, how long or how many seconds, how many seconds does the wrench hit, after how many seconds does the wrench hit the ground? Okay, so the key word is after how many seconds? Okay, and it hits the ground. So when it hits the ground, H is going to be 0 when it hits the ground. right? Ground zero. And they want to know, you know, after how many seconds does it hit the ground? So we're interested in here, in this point here, and where does that point occur? So after how many seconds? So we're looking at time, because between 0 and that green dot, the ball is, or not the ball, the wrench is in the air and then it's hitting the ground. So there again, we're going to have to estimate. This here is 4.5. So it's between 4 and 4.5. So I don't know, let's say approximately 4.3 seconds. So therefore, the wrench hits the ground after 4.3 seconds. All right, there we have it. So we used the graph to answer certain questions like what height was the wrench dropped from, how long did it take to hit the ground, and then they asked a particular question like how high off the ground was it after 3 seconds. So I hope the video helped. Thanks for watching.